Before we can start talking about simplifying square roots, we have to first understand what a square root is asking. So, if you were asked what the square root of 4 is, you would say 2, because 2 squared, or 2 times 2, equals 4. So what the square root is asking is it's saying what number multiplied by itself would give us this value. Another way of thinking about it is what number squared would give us this value. That is the basic definition of what a square root does. So in order to simplify square roots, the most important thing to know is some of the perfect squares. Perfect squares are the numbers that you would get from multiplying something by itself. So, one of the smallest perfect squares is 1, because 1 squared, or 1 times itself, gives you 1. The second is 4, because 2 squared, or 2 times itself, gives you 4. Then 9 from doing 3 squared, 16 from doing 4 squared, 25, 5 squared, 36, 6 times 6, 49, 7 times 7, 64, 8 times 8, 81, 100, 121, 144, 169, 196, and 225. Those are the ones that you should have memorized or know. That's 15 squared, that's 14 squared, that's 13 squared, that's 12 squared, and you get the idea, okay? So when it comes to simplifying square roots, if it's a perfect square, it's pretty simple. Anytime you're taking the square root of a perfect square, you can just have them memorized, or you could think of what number times itself would give you this value, and that's your answer, okay? Because this symbol, the square root symbol, is asking us a question, once we have the answer, we don't write the square root symbol anymore because we have provided the answer to the question. Then, what do you do if you have values under the square root that aren't perfect squares? So, for example, if I was to ask you to find the square root of 27, 27 isn't in this list, so then the idea becomes, is there a number that I could divide 27 by that is a perfect square? Or another way to think of it is, what are the factors of 27? Are there some which are perfect squares? So we could break 27 into 9 times 3. I would want to break it into these two numbers because 9 is a perfect square. So then I could just take the square root of 9, which is square root of 9 is 3. And then I don't know what the square root of 3 is, so I'm just going to leave it under the radical. And because 3 doesn't contain a perfect square, isn't divisible by a perfect square, that's my final answer, okay? Another example. If I was to give you the square root of, let's see, 18. Now think about this. You could do 3 times 6. Neither of those numbers are perfect squares, though. You could do 18 times 1, and 1 is a perfect square, but then you would just get the same thing that you had before. So you would want to break this into 9 and 2, because 9 is a perfect square. So then the square root of 9 is 3. Square root of 2, I don't know, so I just leave it like that. And keep in mind, the square roots of 3 and 2, they're all decimal values, because a number times itself that gives you 3, there is no whole number, so it's a decimal value. Ignore that add at the top. Okay, same thing for the square root of 2. It's a decimal value. So that's why we leave it under the radical instead of simplifying further. Okay, some more complicated examples. Let's just keep going. If I was to ask you what the square root of 32 is, let's think about it. You could do 4 and 8, right? The square root of 4 is 2, and 8 I would leave under the radical. But for this particular problem, you would want to keep going. You would want to keep simplifying because the number under the radical is still divisible by a perfect square. So I would keep going, and I would break 8 into 4 times 2. Square root of 4 is 2 again, so now I have 2 times 2 outside the radical, which is just going to be 4 root 2. Now, what that means is because there was a 4, or because there is a 4 outside the radical, that means that this 32 could have been broken up into 16 times 2. If you want to confirm that because you don't believe me, there it is, 32. So this I could have also done by just taking the square root of 16, which is 4, and leave 2 under the radical. Notice I used 2 different methods, but regardless, I still got the same answer. So there's so many different ways that you could do these problems or think through them, but regardless, if you're doing correct math, you're going to get the right answer. Okay, let's break up a number, or let's do a number that's even bigger. So let's do 96. Is there a perfect square that goes into 96? Well, I know 3 and 32. And I know what 32 simplifies to because I just did that one. So I would break up 32 into 16 and 2. So this would be 4 root 3 times 2, or 4 root 6. Which again, you could have gotten this answer doing it a whole bunch of other ways. I could have noticed that the square root of 96 is also equivalent to 4 times 24. So square root of 4 is 2. Leave the 24. But the square root of 24 has a perfect square that it can go into. So 4 and 6. Square root of 4 is 2, so 2 times 2 on the outside, and notice I still get the same answer. Different ways of doing it, still get the same result. Okay, let's try another one. Square root of 175. Usually anytime I see a 5 at the end of the number, I assume it's divisible by 5. I could also think about quarters here, right? This has 7 quarters in it. I don't know if that makes sense to you, but if you work with money, it probably does. But if not, I'll just divide by 5. So 5 times 35. If I break up 35 even more, that's 5 times 7. This is another way to think of it. Because I have a pair of 5s, I know that I have 5 squared, which is just 25, right? But the square root of any quantity squared is just going to be that number. So 5 root 7. Now, if I was to do that quarter idea, 25 times 7 also gives me 175. Okay. And then the square root of 25 is 5. Square root of 7, I leave it under there. Okay, I'm going to just do a few more examples, make sure we're understanding this, and then we're going to move on. What if I have 3 root 405? Again, because there's a 5 at the end, I know that this number is divisible by 5, so I'm going to break up the 405 into 5 times 81. And that's actually perfect because the square root of 81 is just 9. So now I have 3 times 9, root 25, which is 27, root 5. Okay, last example. 12 root 100, or 1,764. Is it divisible by 4? It seems like it, so let's try it. 4 can go into 1,764 441 times. Let's confirm that. 1764 divided by 4. Yep, 441. I know that the square root of 4 is 2. So I have 12 times 2 and 441 under the radical. Are there any perfect squares contained inside of 441? Let's just try something. I know 4 can't go into 441 evenly. Maybe 3 will go into 441 evenly. So let's see, we have 12 times 2, which is 24. 3 times, it can go into that once. It can go into 14, 4 times, and then 7. Okay. Let's keep breaking that apart. Let's see if we get any pairs. So I know 7 can go into that 21 times. And then look at that. 21 can be broken into 3 times 7. So I actually end up with 2 pairs of numbers. So this is going to be 24 times 3 times 7. 24 times 3 times 7. I'm just going to use the calculator. That's going to be 24 times 21, which is 504. So notice, what did we pull out? We pulled out a 3, we pulled out a 7, and earlier we had pulled out a 2. So what that means is 6 times 7, which is 42. So that means 42 squared is equal to 1,764. And there it is. And that's how you simplify square roots. Now the square roots with the negatives is basically the same thing. The only difference is if you have a negative under the radical, you just have to pull out a I. So 3 root negative 900, for example. The square root of 900 is 30. But because it's negative, I'm going to pull out 30i. So 3 times 30i would give us 900i. One more example, square root of negative 72. I could break that into negative 9 times 8 and break that into negative 9 times 4 times 2. So that would be 3i times 2 root 2, so 6i root 2. And that's how you simplify square roots using perfect squares and when there's a negative under the radical.